Our third and final method for solving linear systems in section 3.1 is called addition. It's often called elimination by other textbooks, but this book likes to use the term addition. Just be aware of that. You probably heard elimination before if you've taken an algebra class before. So our steps for solving a linear system using addition. Our first step is that we're going to multiply either one of the equations or both of the equations by a number or two numbers, depending on the problem, so that when the equations are added, one variable will cancel out. So that's our goal with addition, that when we add the two equations together, one of the variables cancels out and we only have one of the variables left, then we can solve the equation for that variable. So after we've multiplied, then we do actually add the equations together. And one variable should cancel out. Because that was our plan in step one. If one of the variables doesn't cancel out, then that means that there's a mistake either in our multiplying step or in our adding them together step. Then step 3 is to solve the remaining equation to get one of the variables. And then step 4 is the same as step 4 with substitution. Once we have one of the variables, we need to get the other variable by plugging in. So we plug into one of the original equations. To get the other variable. So those are my steps. We're going to start by looking at example problem 5. Now notice in this problem, I have both equations with x and y on the same side, and I don't have any x or y that doesn't have a number in front of it. So substitution is not going to be a good method to use for this problem. Some of the problems can be done with either addition or substitution. Some of the problems, the way that they're set up, it's going to make one method or the other a little bit easier. So this problem, I need to do addition because substitution, like I said, there's no x or y that doesn't have a number in front of it. So my equations are 3x plus 4y equals -10, and 5x minus 2y equals 18. Now, you can work with eliminating either the y or the x. It depends on what you prefer. Sometimes the numbers in the problem make one easier to work with than the other. In this case, the book shows eliminating the y by multiplying the bottom equation by 2. So you can do it that way. I'm going to show a different way just so you can compare both methods. I'm going to show eliminating the x. And so When I look at this, I have 3 in front of the x in the top equation and 5 in front of the x in the bottom equation. So I'm going to multiply by 5 on top and by 3 on the bottom. That's going to make them both 15. Now I need one to be positive and one to be negative in order for them to cancel out. So I'm just going to pick the top one to be negative 5. I could put negative 3 and positive 5. It doesn't matter. You should end up with the same answer. But I just need to pick one. So what I'm going to do is multiply everything in the top equation by negative 5, everything in the bottom equation by 3. So that includes all 3 parts here, the x, the y, and then the number by itself on the other side, and then all 3 parts for the bottom one as well. So when I do that, I'm going to get negative 15x minus 20y. Negative 10 times negative 5 is positive 50. You need to be really careful with signs here. One mistake with the sign, getting it wrong, is going to mess up the entire problem. Now I'm going to distribute the 3 into the bottom equation. So multiply everything in the bottom equation by 3. That's going to give me 15x minus 6y. 18 times 3 is 54. Use a calculator if you're not sure. Now, what's going to happen here is that my 15x and negative 15x, when I add those together, it's just 0. So that makes the x's cancel out. And that gives me an equation that only has one variable in it, which is y. Add negative 20 plus negative 6, and it's negative 26. Add 50 and 54, and that's 104. So my x is gone. All I have to do now is solve for y. So I'm going to divide both sides by negative 26. And that should give me y equals negative 4. So now what I need to do is plug into one of my original equations to get the value for x. This is a little bit more work than it was in the substitution problems just because there's a little bit of solving involved. I'm going to pick the top equation, but it doesn't really matter. If one of the equations looks a little bit easier, you can go with that one. I can also plug into the bottom. I should get the same thing. So I'm going to plug negative 4 in for y into 3x plus 4y equals negative 10. And then I'm going to solve that for x. So multiply 4 times negative 4, that's minus 16. Then I need to add 16 to both sides. Negative 10 plus 16 is going to be positive 6. And then lastly, divide both sides by 3. And I get x equals 2. So my answer that I would type into my math lab is 2 comma negative 4. Make sure you're putting x first and then y, and putting parentheses around the answer. So that's example 5. Like I said, in the book, you'll see that they do it a little bit differently because they multiply the bottom equation by 2 and then eliminate the y instead of the x. But you can look at that. What you should do next is checkpoint problem number 5. A little warning about checkpoint problem number 5. One of the variables will come out to be a fraction. You'll see that when you look at the answer in the notes. Generally for the homework problems, you should not get any fractions. They all should come out to be whole numbers, but the book decided for some reason to put a problem in checkpoint 5 where one of the variables is a fraction. So just be aware of that. So you should do this problem in your notes, check with the notes that I have posted, and then move on to the homework.